All right, we'll continue on with day 5, part 2. So, continuing on with the variable types. Helper variable. This is similar to a calculated variable. This variable is the result of a formula calculation. They are global variables that are required when the number of parameters required for a post formula cannot be passed within the argument space available, which is just a fancy way of saying that we have some functions that return more than one value. And so they had to build these special variables to receive multiple values back, because originally a formula in MP was restricted to only returning a single value. Boolean result. As this description implies, the value of the result of a conditional branching statement or formula that returns -1, 0, or 1 as a result. 1 being true, all other values being false. System data variable. Values from either the system, your computer, or from Mastercam directly. Control definition variable. Predefined variables whose initial values come from the control definition. So typically these are noted in Mastercam's generic posts with a pound and then CD_VAR comment. File name variable. The command line file name string passes strings passed to MP. I don't really think I think technically that's a string variable, but that's okay. Values for all numeric variables are stored as double precision floating point values. There are no separate classes of variables for integer and non-integer values. Use format statements to control the number of decimal places and appearance when variables are output. Now this, I'll have to look and see if it's in this documentation. It might only be in 2018. But there's a new type of variable called an enumerator, which is basically a limited variable type. It takes up less overhead in memory, and it's only designed to store a constant integer value. So I'll find the documentation that may be somewhere else in this guide, but there's some documentation that talks about enumerator values. I usually stick to the basics because learning how to format variables, that's really what you should be focused on when you're initially learning to edit posts anyway. So, user-defined variables. User-defined variables must be declared before they are used. This is a typical example of a statement that declares a user-defined variable and initializes it with the value of 0. So here's a variable, starts in the first column, USE_GEAR, use gear. And then it's initialized with the colon character, and we're initializing it to a value. Now we happen to be using it as a switch. You can use it as a switch, or you can perform calculations with it. There's no restriction on a variable. When you define a normal numeric variable type, which is the double precision floating point number, there's no restriction on whether or not you only use it as an integer value or whether or not you do something else with it. Okay, good. So it looks like we'll get to the enumerator in a couple pages. Good. Thanks, Jeremy. To declare the variable, simply state its name in the first column. The variable name must follow these rules. It always starts in the first column of your post. It begins with a letter. It contains only letters, numbers, and the underscore. Can have a maximum of 25 characters. must be defined outside of a post block. Because the declaration takes place in the first column of the line, a variable declaration has the effect of ending any post block in which it is declared. For this reason, it is good practice to declare your user-defined variables near the beginning of your post, before your post blocks. And this is my recommendation as well. Although sometimes you'll see me create a variable directly in front of a post block where I'm using it, that's just to save time. Best practice is always to declare your variables, to initialize them at the top of your post. You are allowed to begin the variable name with any letter, but your post will be easier to understand if you avoid the letters P and S. P is typically used for post blocks. S is typically used for string variables. The second part of the statement above assigns an initial value to the variable. The colon character is the initialization operator. You can assign a value using any of the following. A number. So here we're initializing it to a number. An existing numeric variable, either user-defined or predefined. Here we are assigning useGear the value of gear max. As a hint though, the definition of this variable on the right must appear above this one, or be predefined. Yeah, note that the value on the right side of the statement must have been already declared if it is not a predefined variable. You can also declare a variable with the result of a mathematical expression. So here we're using gear max minus 1. Predefined variables that are initialized in the control definition cannot be initialized again with a different value. However, you can assign a different value to the variable inside a post block. No matter where a variable is declared, it is visible to all post blocks and is available with its initial value. As a convenience, you are also allowed to declare variables inside a format assignment. Variables declared in this way always have an initial value of 0. And we'll get to that when we do formatting numeric variables. Another alternate way to initialize a variable is with the equal sign instead of a colon. Be careful when you do that though, because this is considered a global formula, which functions differently than declaring the variable with a colon. When a numeric variable is declared with a colon, the value that is to be assigned to the variable is evaluated when your post is parsed. This occurs before any processing of the NCI file. These are the values seen when the NCI file read is started and MP starts calling internal routines and post blocks. MP never re-evaluates the value, numeric variable, or formula after your post parsing is completed. When a numeric variable is declared with the equal sign, MP re-evaluates the value, numeric variable, or formula that was assigned in the declaration every time MP encounters the numeric variable on a post line and before the numeric variable output or evaluation when inside a formula. See the numeric variable new global, which controls global formula behavior. The use of global formulas is not recommended. In addition to introducing excess overhead during processing, they can make debugging difficult if you are not aware that a numeric variable was declared as a global formula. If you choose to use global formulas, the numeric variable new global $, should always be set to 1. Do not confuse a global formula with standard post lines that assign new or calculated values to variables. This is all about position, because if the line starts in the first column of your post, MP interprets it as a global formula. If it is indented, MP interprets it as part of a post block. For example, consider the excerpt from the PSOF post block. Because the post line tool change equals 1 is indented, MP considers it part of the PSOF post block and not a global formula. In this example, the same expression is in the first column outside of a post block, and so Mastercam considers it a global formula. So if this is true, if this is starting in the first column, even if we said somewhere down below tool change equals 10, as soon as we tried to read it as part of any logic in the post, it would always be set to 1. Because before we evaluate it, it reads the global formula if it exists. Use the colon equals operator to initialize a variable to a fixed value. Variables initialized with colon equals will not be allowed to be modified during runtime. Typically, this is used to create numeric constants that can be more easily referenced by their names. Now, they tell you that it will not be allowed to be modified during runtime, but then earlier they say don't try to assign a value to it because you'll screw things up. So there's some inconsistencies here in the documentation, and honestly, I've never tried to assign a numeric constant a new value. I've always known not to do it, so it's never been an issue for me. I would say if you're going to use a constant, let it be a constant, and don't try to assign it a value inside of a post block. So, one of the things that they didn't mention up above for numeric variables is a new variable type that was just introduced. So introduced in Mastercam 2017. That means if there's anybody in the class who is not using Mastercam 2017, be aware that this may not work for you. Now, typically, when they announce a new feature in the post language, that feature has actually been around for a couple of versions. They do that to make sure that they can debug and test and use stuff internally before they release it. So I wouldn't be surprised if this was actually available to you in X9 or even X8 maybe, but there's no guarantee. So the official word is don't use it until 2017, but I wouldn't be surprised if you could try it in one or two versions previous and have it work. If you tried this in X6, it would definitely not work. I can guarantee you that. So another way to create and manage constants. And what is a constant? A constant is simply a numeric variable that is designed to be to have its value be created and never changed during the running of the post. When you define a numeric constant, it does start in the first column, just like a regular variable name, and they've got some conventions down here. So by convention, and convention is not a hard and fast rule, it is just like a recommendation, right? The only thing that's required is that you end the name of the enumerator with the @ symbol, but they also recommend as a convention that you use all caps. And really this is to help separate these from the standard numeric variables. The idea being these are only integer values and the values don't ever change. So by convention, enumerators are labeled in all caps to make your code easier to read, although this is not a requirement. Use a set of enumerated values as an efficient alternative to a variable whose value will only be one value from a limited number of states. By design, enumerators are intended to be a lightweight alternative to numeric variables. When you create a numeric variable, MP does a considerable amount of work behind the scenes, such as creating the data structures to manage modality, previous values, extended values, and so on. This is that overhead I was talking about. You might be able to create a simpler, more efficient, and more maintainable code by instead creating an enumerator for each possible value or state and using those directly. Follow these rules. Enumerators can have integer values only. They are not intended for output. Do not assign a format statement to them or use them in a format assignment statement. You cannot change or reassign their values. And remember to always include the @ symbol, or the @ symbol, when referring to them in your code. This example uses enumerators to define options for outputting canText or Colin, before the adjacent line, on it, or after. The enumerated state is passed as an argument when pcanText is called to properly configure the output. So here they're showing p_my_post_block. There's an indented call to pcanText, and we're passing the value of before @, which is 1, to the post block. So now in pcanText, so if canText number is greater than 0, update the output position. Output position equals the absolute value of output position. pcanText flush flag init. So this is funny because they're showing calling it with before. And okay, so what we're doing here, this is kind of funky and it's kind of hard to get if you haven't worked with passing values before. So here we're calling p_my_post_block. Then inside it, we are making a call to pcanText, and we are passing a value. That value, whatever it is, gets stored in whatever variable is inside the parentheses on the pcanText declaration line. So the value of before gets loaded into output position. This is the variable passing part of the equation. So if we had called pcanText with the value after in the parentheses, then a value of 3 would get passed to output position. So basically, whatever we put inside here, we're passing to this variable, and now it can get evaluated down here in the output lines. Notice it says, note, the entire post block is not shown in this example. Oh, what do we got here? There's a thing here on declaring values for lookup tables. We're going to skip past that. We're going to focus on numeric variables today. Let's see how we're doing for time here. Yeah, that's good. All right, we've got about 10 more minutes. So, when you format a numeric variable, you specify how it should appear when it is output to your NC program. For example, a variable whose value is 20 might be output in any of the following ways, as simply 20. For example, if it is a G code, G20. Followed by a decimal if it is a coordinate position, for example, X20. It also might include a specific number of trailing zeros, for example, X20.000. Or it might be output as no decimal point, but preceded by leading zeros, for example, if it is used as a sequence number, so if it's N20 or N0020. The control for your machine tool typically has specific requirements for how different types of numbers should appear. Beyond that, your shop might also have its own standards and conventions. Use numeric formatting to output values in exactly the desired format. There are 2 steps to creating variables, or to formatting variables. First, create format statements that describe a specific numeric format. For example, a numeric format might be described as force a decimal point, 4 digits after the decimal point, and pad with trailing zeros if necessary. You can create up to 30 different formats. I believe this is slightly incorrect. I don't believe the number of formats that you can create is actually limited. I believe you can create hundreds of formats, but if you need more than 30, you're probably not using them in an efficient manner. Most of the time, most posts start with somewhere around 20 format statements, and you might need to create a couple more of them, but in general, the existing ones typically handle what I would consider to be standard output, and we'll be going through what each one of these does as well. Second, create format assignments to tell MP which format statement to apply to specific variables. These also let you apply prefixes and suffixes to the numeric value. The most typical example of this is to include NC address labels with a number. A format statement might be described as, or a format assignment might be described as, format the value using format statement number 2 and precede the number with Y. So by combining the format statement and the format assignment, you can specify that a variable whose value is 4.12 be output as Y 4.1200 in your NC program. Format assignments typically are going to do more truncating than anything, because a lot of time with our values we're going to output them. Format statements. The MP language supports 2 types of format statements. Type FS declares a single numeric format. Type FS2 defines a numeric format that includes separate formats for inch and metric. MP automatically applies the proper format depending on the Mastercam configuration. So this is the configuration of your actual Mastercam file. Is the part file inch or metric at the time the NCI file was generated? MP selects the numeric format, either inch or metric, based on the value of the MET_TOOL METTOOL $ variable. So METTOOL is used inside the post to determine whether our output is configured for metric or whether it's configured for inch. You can define a maximum of 30 format statements. Yes. Sorry. You can define format statements. Most are typically limited to 30 and use the numbers 1 through 30 to identify them. Either format statement function may be used in your post, but cannot share the same format statement number. For example, this would not be valid. So in this example here, we're showing FS, couple of spaces, the number 1, and then one column of numbers, 0.7. For the FS2 type, we're showing a value of 1, which is what makes this incorrect. We would have to change this to 2 or some other number, and then 0.6 for inch, or 0.7 for inch, 0.6 for metric. It's always the inch column first, followed by the metric. So, format statement is usually not encountered very often in a post. We almost always use FS2. If you look at this table, it talks about the pieces of information that are typically included on a format statement line. But it's a little hard to read in this format here. You know, it talks about what each one of these things are from left to right as you go across the format statement line. It's easier to see here when we look at the little chart. So when we're talking about defining a format statement, its first, I guess, thing that defines it or lets MP know that it's going to be a format statement is to have the F character in the first column, followed by an S, followed by a space. So I guess that's something they don't show here on the chart. You have to have at least one space here. Then you have the actual format statement number, 1 through 30. There is always another space after the format statement number. So I don't know if they talk about it. Yeah, talk about it down here a little bit. Then we have this optional character. Optional meaning it's usually left out, but it can be added if you need it. And that optional character is either an S or a plus sign. The S tells it to force the space. So force space before the output. The plus is used to force a positive sign. By default, when we output numbers with MP, positive numbers are just output as numbers, and negative are signed negative. By adding the plus sign here, we would sign all values, positive or negative, that used this particular format statement number. Next we have a column, which is a number, a separator, and a number. So the column is read like this. Number of digits before the decimal. This is the integer digits, with 0 being any number. So a 0 in front of the decimal point can contain any number of integer digits. Then we have the separator. The separator is either a decimal point, a comma, or a space. The space being no separator. Then we have the number of decimal digits. So this is the number of points after the fractional digit. And there's an optional second character after the number of decimal points, the number of decimal digits. And that optional second character is either a 2 or a 5. And the second character here controls rounding. It controls partial fraction rounding. A setting of 2 meaning round to an even number, 0, 2, 4, 6, 8. A 5 being round to 0 or 5 for the final digit. So some of those controls that only have like 5/10,000ths of an inch resolution, 0.0005, they can only go to like 1 thou or 5/10 or 1 thou and 5/10, but they can't go to any finer than that. We can control the output. Remember, this is FS type 1, so there's only one column of numbers. And then at the end, there are these optional attributes, and they are contained by these capital letters: L, T, N, D, I, or Z. And each one of them has a special function. L keeps leading zeros. T keeps trailing zeros. N forces the value's output to be non-modal. A D or an I allows you to select between delta output or incremental. So delta will show you the absolute change, even if that change is 0. Incremental will only output when it is not a 0 value. And a Z character can be used to keep the trailing 0 after the decimal for a whole number, which will force 1 decimal point to be output as 1.0. Format statement 2 is the exact same thing as format statement 1, with the sole difference being that there are 2 columns of numbers. There's a column for inch and there's a column for metric, and MP automatically chooses the appropriate column based on whether you're outputting a metric file or an inch file. Now, I don't know about you, but when I see this little chart right here, like my eyes tend to like glaze over and like roll back in my head, right? It's like a lot of stuff to throw at you when you see something like that. But format statements are pretty simple to understand once you start using them. Okay? Most of the time you don't use anywhere near these number of characters. So actually, before we start looking at some actual format statements and messing with the output and doing all that stuff, it's middle of class anyway, let's go ahead and take our 10-minute break. So we'll take our 10-minute break. As always, feel free to post up any questions if you have them at this time. Otherwise, when we come back, we'll start taking a practical look at format statements and how to use and modify them.